Okay viewers, now we are on the sixth hands-on for designing and implementing a data science solution on Azure, and within six hands-on we'll work with data. Okay, so I have opened this link here. Now to run any kind of data science experiment or to run any data science algorithm, we need a data or a data store where we can store our data and then apply our machine learning algorithms, do all kinds of analysis on the data set, right, and then get the insights. So usually the common way to do any data science project is to store the file in our local system and then run all kinds of analysis on that data. But in enterprise environment, it can be stored on a different location, either on the cloud or on-premise location, right? Now, a data scientist role would be to run the machine learning algorithms, do all kinds of analysis on the data, which are from different sources, either from cloud on premise. Okay, so that's what we are going to learn here. So in this exercise, we will explore data stores and dataset, which are the primary objects used to abstract the data access in Azure Machine Learning. So within the Azure Machine Learning, we'll have abstraction of data stores and datasets from where we can refer the data and run the machine learning algorithms on top of that. Now, prior to running any kinds of machine learning algorithm, we have to do some setups related to Azure Machine Learning Workspace, and then opening the Machine Learning Studio to access the Jupyter Notebook, where we'll be running the machine learning algorithms and the scripts. Okay, now to run this Jupyter Notebook, we also need a compute instance or resources, Azure, which is the Azure resource to run our Jupyter Notebook scripts. Okay, so that would be a compute resource. So all those things that I have mentioned are related to Azure Machine Learning Workspace creation, opening the Azure Machine Learning Studio. All those are covered in my previous YouTube videos. Please check that. Now, moving on. I will open the Azure Machine Learning Studio and then start my compute resources. Okay. So here I have already opened my Azure Machine Learning Studio in one of the tabs, and I am into my notebook section or notebook page. Here we are going to run the sixth hands-on. So I will open this notebook, work with the data, and I have kept my compute instance running. Now what is compute instance, how to create that, all that is covered in my previous video, so please have a look into that as well. I have started my compute instance here, which will be used to run my Jupyter Notebook. Now here we can keep notes as well as run the Python scripts within the Jupyter Notebook environment itself. I'll minimize this sidebar to have a more space. So on the sixth hands-on, we have work with data. Data is the foundation on which machine learning models are built. Managing data centrally in the cloud and making it accessible to teams of data scientists who are running experiments and training models on multiple workstation and compute targets is an important part of any professional data science solution. In this notebook, you will explore two Azure machine learning objects for working with data. One is data store and then data set. So here we have the data store, and then we will have data set. To get started, connect to your workspace. I have already connected and I've kept my instance running, computer instance running. Now, here this is just trying to print under which version of Azure Machine Learning core package we are using. So if I run this, you'll be able to see the Azure Machine Learning version, right? And then Machine Learning Workspace. This is nothing but a virtual separation of workspace where I am running all my machine learning scripts and algorithms and storing my Azure data, right, under this virtual workspace. Now work with data store. In machine learning, data stores are references to store locations such as Azure Blob Storage Container. Every workspace has a default data store. So this machine learning workspace that I have created will have its own default data store, usually the Azure Storage Blob Container that was created with the workspace. So it was already created with the workspace. Okay. If I'll open this portal.azure.com homepage, and then I'll go to my machine learning workspace. There you will see this is my keyboard, this is my resource group. Let me go to the resource group. Here you will see account or storage, which was already created as part of my workspace. Okay, this is for insights, and this is my keyboard to store some secure keys while exposing my trained model as a service. So it will have authentication keys which will be stored within this machine learning keyboard. Anyway, coming back to that Jupyter notebook. Now to work with data store, we have this data stores, which is part of our workspace cell within the data. So let me run this cell. Here you see Azure Machine Learning Global Dataset is false. Workspace file store is false. File store is not there. Blob storage is true. That means we have blob storage created. Directory based, working directory based, that is also false. And then artifact store is also false. So this is just showing all the data stores that we have within our workspace. So out of that, only blob storage is true. That means we only have blob storage within the workspace or within this data store. You can also view and manage data store in your workspace on the data stores page. So if I'll open this data stores page in a different link, we'll be able to see the data stores. So here you see all these data stores that was printed there: directory based, artifact based, blob storage, file storage, and Azure ML global dataset, right? Next, upload data to a data store. So if we have some data in the local system and we want to upload it to the cloud, like in data store, right? So we can do that and then run our experiment on the data store, which is part of the workspace. Okay, so now that you have determined the available data store, you can upload file from local file system to a data store so that it will be accessible to experiments and running in the workspace regardless of where the experiment script is actually being run. Okay, so when we upload the files, this is the part where we are uploading the file from data CSV, from data folder, which contains database diabetes.csv and diabetes2.csv files, and it will be stored within diabetes data in this folder path in the data store. And overwrite option is true. That means if there is a file existing with the same name, it will try to overwrite. And show progress will show the progress of the file upload. So let me run it here. So uploading an estimated of 2 files. So here 2 files we are uploading. First file is uploaded and then second file is also uploaded. That's the progress it is showing. Now work with datasets. Azure Machine Learning provides an abstraction for data in the form of datasets. Okay, so this is a layer of abstraction on the data. So any data will be stored within dataset. That could be in tabular or file format. Okay, a dataset is versioned reference to a specific set of data that you may want to use in an experiment. Okay, and that dataset could be tabular or file based. Now create a tabular dataset. Let's create a dataset from diabetes data that we uploaded to Datastore in the previous step, and view the first 20 records. In this case, the data is in a structured CSV file, right? So we will use a tabular dataset. So here we are using a import command to import dataset library from this Azure ML core. Okay, and now using that library we will be getting the default data store, and within that data store we'll create a tabular dataset from the files that we have within the diabetes data set. So from this data store we will take the file and then create a tabular data set within the dataset section of the workspace. Okay, and then here we are trying to print first 20 records of that data frame or tabular data, which is nothing but a pandas data frame. Okay, so let's run it. It's going to take time because we have 2 files within this diabetes data and each of these files are being uploaded. Okay, so now within this tabular data set it has printed patient records, first 20 patients records. Here we can see, right? As you can see the code above, it's easy to convert tabular data set to a pandas data frame, enabling you to work with the data using common Python techniques. So that's the advantage of using the pandas data frame. We can run our Python commands or scripts or techniques onto that data frame easily, and it will be much faster in terms of performance as well. The dataset we created as a tabular dataset can be read as a data frame containing all of the data in the structured files that are included in the dataset definition. Okay, this works well for tabular data, but in some machine learning scenario you might need to work with the data that is unstructured. So there could be a structured and unstructured dataset and you may simply want to handle the data from files in your own code. To accomplish this, you can use a file dataset, which creates a list of file paths in a virtual mount point, which you can use to read the data in the file. So you can work with the tabular dataset, which is the more structured data, or you can use unstructured dataset, which could be in the form of a file. So you have to import the file and then read the file and then do all kinds of apply all kinds of technique for machine learning. Okay, so here we are creating a file dataset. So these are the 2 files with the path mentioned here. Okay, if I'll open this in a new link, new tab, here you will see all the data set that we created. Okay, so that's the diabetes data set, and these are from previous experiment, all these. So this is tabular form, right? It is showing as a tabular form. You can explore here this tabular data set. Also, this one is a file data set. So you'll have a file, and which is shown as a this one. It will have a file path basically. If you see here. Anyway, so now the file data set has been created. Now register the data sets. Now that you have created data sets that references the diabetes data, you can register them to make them easily accessible to any experiment being run in the workspace. So a registration of the data set is required so that it could be used in our machine learning experiments. Okay, it could be accessible to our experiment, and whatever the scripts or codes that we have written in this Jupyter notebook is nothing but the experiment we are going to run the dataset. So we'll register the tabular dataset as a diabetes dataset and then file dataset as a diabetes files. So this is about registering the tabular dataset and then file dataset. We are writing it under try except block to avoid or print any kind of exception happening during creating that or registering this dataset. Okay. So let's run this cell, and here we see datasets registered. Okay. Otherwise, any exception will come, then it will be printed from the exception block. So you can view and manage dataset on the dataset page for your workspace, right? In Machine Learning Studio, you can also get a list of dataset from the workspace object. Okay. We can also get it through this script, or we can also open this link in a new tab to check what all kind of dataset and file dataset and tabular dataset has been created. If you see here, diabetes dataset and diabetes file dataset has been created. I'll open this link. This is file dataset. Here we see the file path, right? And within each file we see the records, CSV records. So these are file dataset, but we can always go and click on display grid so that it will be shown as a tabular form. Okay, but this is to just show the files data in the form of table, but it doesn't changes anything in the files. But here in tabular dataset, it's already in the form of a table. If you click on explore, it will just show the tabular data. Yeah, you see. Now, the ability to version dataset enables you to redefine dataset without breaking existing experiments or pipeline that rely on previous definition. By default, the latest version of a named dataset is returned, but you can retrieve a specific version of data by specifying the version number like this. Okay, so any new data that we are creating with the same name, there will be a versioning for each of the dataset. So this way you can identify for which dataset you want to run the experiment. So through this you can call the right version of the dataset and then run your experiment. Train a model from a tabular dataset. So this is all about training a model which is named as diabetes training from tabular dataset. So within this folder, this script will run and save everything. Okay, all the models and everything will be stored within this folder location for this particular experiment. So let's run it. That folder has been created first, and then all the things will refer or write within that same folder. Okay, here we are referring diabetes training Python script to run the experiment, which is within the experiment folder. If I'll expand this experiment folder, diabetes experiment training diabetes training. So this is the Python file which is trying to refer from the experiment folder. It is not shown here, maybe it is hidden, but anyway, ml experiment files. Anyway, we'll see that later. Let's move on. So it is referring the script from experiment folder, okay, and then doing all these kind of imports: scikit-learn, numpy, pandas, Azure Machine Learning Core library, argument, and OS. All these libraries are being imported. And this is about loading the data in the form of data pandas data frame, labeling the features, then creating the training and test dataset split, and then running the logistic regression was some default parameters set here, and then calculating the accuracy of the model and saving the model into the folder that we created earlier. Diabetes training from tabular dataset. So let's run this cell. And our training is complete, which took less than a second. And here we can see this training, diabetes training Python model being written here. Okay, so let me refresh this, and we'll see this folder, diabetes training from tabular dataset. So here we see the diabetes training Python file, right? Note, in this script, the data set is passed as a parameter or argument. Okay, so this one, data set being sent as a argument here. In this case of a tabular dataset, this argument will contain the ID of the registered dataset. So you can write code in the script to get the experiments workspace from the run context, and then get the dataset using its ID, like this. Get context. From this get context will select the correct experiment from the workspace, and then from that workspace we are going to identify the training dataset by that ID, dataset ID, and then we will import that dataset to as a data frame, pandas data frame. Okay. Azure Machine Learning runs automatically identify arguments that reference named dataset and add them to the runs input dataset collection. So you can also do dataset from this collection by specifying its friendly name, which, as you will see shortly, is specified in the argument definition in the script run configuration for the experiment. This approach taken in the script above. Okay, so here we are using the named instance. Okay, friendly name to import the data, okay, or refer the data set. Now you can run a script as an experiment, defining an argument for the training data set, which is read by script. Okay, so the dataset class depends on some component in the Azure ML data prep package. Okay, so we need to include that package into the environment where the training experiment is running. So we'll import that as well, okay, into the default package. So here, core component, experiment, script run, configuration, environment, all these are being imported. Then from Azure ML widget, we are using the run details widget, okay. Then environment configurations are being referred from the YAML file, and then we are importing diabetes dataset, okay, from the dataset assets, which is part of our workspace, okay. Now script configuration. So this is all about referring the diabetes training Python script. So this has all the logics to split and train within the training and test dataset, and then running the experiment and running the model. So this script will do all those kind of things, and then the output of that configuration, we are going to use that configuration here to submit the experiment, run the experiment, and then show the result from that run instance, okay. So run details will be shown as a Azure ML widget, okay. So let's run this experiment, and once the experiment will be completed, we'll be able to see the result here in the form of a widget with all the logs and everything. So here the widget is showing the status is running, that means the experiment is still running, okay, and logs being printed here. Okay, still running. Finalizing accuracy, it is showing 0.789, so around 79% accuracy. View run details will show up here within the experiments, all these details, but we can also check within the widget itself, completed with all these information, right, completed with all these information, right. Here as well, accuracy is 7.89, right, AUC. All these information we are seeing here, and the logs. So that will all be shown as the output of the Jupyter environment, okay. So run details are being shown here, and this is the run ID or the experiment created to run this on our data set. Now note the input data argument passes a data set as a named input that includes a friendly name for the data set. So we have seen earlier also that we use the friendly name to refer our data set. Into this experiment as well, we are using the friendly name, diabetes data set, okay, rather than ID on the data set. Anyway, so the first time the experiment is run, it may take some time to set up the Python environment. Subsequent runs will be quicker, okay. When the experiment has completed, in the widget, view this log, output log, and the metrics generated by the run. So these are all the logs being generated by the run. So if we refresh this, downloaded logs, Azure ML logs, will be able to see the logs here for our experiment. Next, train a model from a file dataset. Earlier we did all kinds of experiment or trained our model on a tabular dataset of diabetes dataset, which we imported earlier in our data store, and then also created a tabular data set and the file data set within the dataset section, right? Now we'll run our model or train our model on a file type of dataset. Okay, so the file dataset would be part of the dataset itself, just like the tabular dataset. So first of all, for this experiment or training, we'll create a different folder with diabetes training from the file dataset. So let's do that. Now folder is created. When we will do the refresh, you'll be able to see that folder now, file dataset, but there will be nothing here for now because this folder has nothing we just created now. Now we'll do the all kinds of libraries being imported to run our pandas data frame, create pandas data frame, run numpy, then scikit-learn, then use the logistic regression, do the train and test split, right? Do the ROC curve and then ROC AUC score. All these kinds of steps we are going to take. Okay, here you see we are again using the friendly name to import or refer our data set, right? But here if you see, it's setting the data set data path instead of data from the table, and here using that name we are trying to refer the CSV files, all the CSV files. So all the training files being set, so all the files which we have within our data set will have the file path as training files slash the files, all the file name. Okay, so that's setting a new path and then referring those files one by one as a pandas data frame, right? And here we are using the pandas function to read the CSV files from a file data set. Okay, so that's why read underscore CSV, it's reading a CSV file, not a table. Okay, and these steps will be the same as for our tabular data set. Features and label, splitting the data into test and training and test sets, running the logistic regression, and then testing the accuracy of the model and calculating the scores, ROC AUC score. Okay, and then storing that model into the output folder. Okay, so all these steps are exactly same except importing the data from dataset part. So this is just different. Okay, let's run it. So this file has been created within this folder. Let's refresh that. So diabetes training.python, this script has been created. You can always click and see the script. This is what we have, right? This is the experiment that we created. Now that script will be used to run here as an experiment. So that script is being used here to run the experiment on the diabetes file dataset. This is nothing but the file dataset within our workspace. Now, if you see the experiment folder, it's referring the same folder that we created earlier, diabetes training file dataset, to store all our logs and training model and everything will be stored here. Okay, let's run this. So here again it will open a widget to show us the status of our experiment, showing the running status. It's running on the training diabetes model, training diabetes data. So this is the experiment ID basically, and it's finalizing the run. It's almost going to complete. Okay, it's already completed now. So here we see the accuracy of our model 0.779, which is around 0.7978 or 78% of the accuracy, and AUC regularization records, and then all the run history, or you can say run logs. Okay, and this experiment run is completed. Okay, these are all metadata related to our experiment. Okay, this will be part of our ML logs here, and then let me refresh this folder again. Okay, nothing else extra. Fine. Anyway, so that's about the metadata and the logs of our experiment. Then restore the train model. Now we have to restore this training model so that it could be again reused. Okay. So to restore the model, we have to run restore model and then refer the output model right from here. I don't know why it's not showing. Then model name diabetes, training context, file data set, and then you see all these matrices are being set here from model in model list. Okay, you can see all the models here. Let me open this model section. So all the models that we created, diabetes model for file data set and diabetes model for tabular data set will be shown here. If we click on this, we will be able to see what kind of data set this was. So from the tag we can see training context, parameterize script with these accuracy properties, all those things. Versions we can see here. Data sets we can see here. Data set is not being shown. And then this one, model 1. MS Learn training diabetes. Training context is correct. Okay. So these are the tags. Here you can see the model, right? Artifacts. You can also download this model and use it to run as a service. We can deploy this model as a service and then input new data or play new data on top of this model to predict the new patient whether they are diabetic or not for this. Okay. So you'll be able to see all the models created here and then also the experiments that we created. Okay. So let's register this one. File data set, parameterize script, this one. Diabetes model version 3. So we already had 1, 2, and then this one is third model created. So if we go to the models page, we'll be able to see the third model. Okay. We can also see the performance of the model. So the last one or the latest one has more accuracy. So this is about working with the data in the form of tabular form or whether the file form. Okay, I'll save this Jupyter notebook and then stop the kernel. So thank you guys for watching. Please like and subscribe my videos if you like it. Bye bye.